Uh, Gord's going to talk to us today about, it was the topic of passive housing. So I think I'm going to find this quite interesting because I thought I had a passive house until I realized maybe it wasn't so passive.
Oh,
Certainly, Gord sounds like he's going to brush us up on passive housing. So take it away, Gord.
Thank you very much. And I will, I want to do this one now. Let's just make sure we're good to go. So is it showing my, my intro slide, energy programs and passive house?
yes.
Well, thanks again, gang, for being online. Hopefully you guys don't get sick of me. John had said, while we're not traveling, before the summer gets started, hey, Gord, there's some topics you'd like to speak on, and one that's near and dear to my heart. Obviously, I shouldn't say obviously, but we are an energy rating company, energy advisor company, and we get asked all the time, what about these various energy programs? And the sort of the quintessential or the be all end all is passive house, or is it? And so we decided that we would give you a little 45 minutes or so on energy programs and passive house, and hopefully lots of time for questions. I often end up talking too much, but don't be afraid to ask questions, I guess is where we'd go. I always like to start, because I'm very proud of the Canadian building science experience, and I always like to start with a few slides related to that, partly because you'll hear that the Passivhaus program out of Germany really came out of the Canadian experience, and I say that with reasonably good authority. And then we'll talk about the compelling trend of energy efficiency in houses. Let's touch in on common energy programs. And the only reason I want to do that is because it helps compare and contrast and helps us understand the specifics of the passive house program. So that's kind of the agenda for today. In terms of Canadian building science experience, this is, I was doing a little bit of research and discovered that the first National Building Code of Canada was published jointly by the National Research Council, National Research Council and the National Housing Administration, which turned into CMHC. That was in 1941 was when it was first published. And the focus was primarily structural requirements and fire safety. Interesting enough, there was insulation in the code, but it was under the section health and sanitation. So the reason we put insulation in buildings is so that pipes didn't freeze and burst, and so that people didn't freeze in the middle of the night if their heating system crapped out. So insulation was in the code since 1941, as were air barriers and so on, other elements, vapor barriers, but under the health and sanitation or health and wellness or health and well-being section of the code. I found that a little bit fascinating. And then it was really in the 70s, that is, our code was already on the science side, but really it was in the 1970s that Canada took a leadership role in energy efficiency. And that was response to the oil embargoes, the OPEC oil embargoes of the mid 70s. And a bunch of research was conducted, some of it there in Saskatchewan. There's the Saskatchewan Conservation House that was built. It was a joint venture of the University of Saskatchewan, the Saskatchewan government, Natural Resources Canada, at that time, Energy Mines and Resources, and they built a demonstration house. And Canada took this leadership role in understanding specifically cold weather housing. And out of that research came the R2000 program. Some of you will recognize that term. That term was turned into a program in 1982. So the R2000 program has been since 1982. And its goal was simply, as they called it, a technology transfer program. They weren't trying to build a whole bunch of houses. What they were trying to do is teach builders how to build better houses. And literally thousands of builders took the training. And to this day, there's a few of them left who would tell me they were the first R2000 builder in Canada. Well, maybe their number was number 22 or number 23, whatever, but they were one of the first R2000 builders. And that was the goal. And the R2000 kind of set the standard both in Canada, and you're going to hear me say, and in other parts of the world, at least with respect to cold weather housing. So be it known that the science of houses, cold weather housing came largely due to the efforts of Canadian building science research. I just think that's cool. And one of the things that the research showed was where the energy loss went. That is, this magic number of 30% of heat loss or energy loss goes to air leakage came out of that work that was done in Saskatchewan and Ottawa and other places, and 25% to basements, and only 5% to attics, oddly enough. And why only 5% attics? Because even in 1970, we were already insulating attics, already had R20 in the attic. And so attics were kind of been there, done that, and it was really the walls and the windows and air leakage that were causing the issue. The other fundamental finding of this research, and it's very germane to the conversation around passive house, is the need to control the flow of moisture to avoid condensation in insulated cavities. I've probably used this line in other sessions I've done with you guys, but we learned that you cannot put insulation in a cavity and allow warm, moist air to leak through that insulation. Warm, moist air leaking through insulation to the cold side of the insulation results in condensation. And in fact, the more insulation you put in a building, the tighter the building needs to be. We hear this all the time, we're building them too tight. No, we're not making them tight enough if we want to insulate them. If you don't want to insulate your buildings, okay, then you can build a leaky building. But if you want to insulate, and the more you want to insulate, the tighter you need to make the building, because you don't want warm, moist air leaking into that cavity. And that came out of the research that was done in Canada in the late 70s and culminated in the R2000 program. And this was kind of the father of, and I show him specifically because he's recognized by the Passive House Institute of the United States as being the father of the program. And he's the guy at the University of Saskatchewan who determined that air leakage component. And as he says here, it was really obvious how to calculate heat loss through walls and ceilings, but was less obvious was this idea of air leakage, and you were pretty much guessing. And there on the right-hand side is one of the early blower doors. I actually have one of the nozzles that we call those nozzles. I have one of those nozzles here in my office because they actually made up at the university a bunch of nozzles out of fiberglass and actually shipped them out to the R2000 builders and said, here, test your own buildings. So they were given this calibrated nozzle. They had to figure out their own way to get it into the house and get it into the door, but kind of interesting. And Harold's 85 now. I spoke with him not too long ago. Just a great gentleman, still interested in advancing housing technology in Canada. And as I say, that first house that they built, the demonstration house that's in Saskatchewan, had R60 ceilings, R40 walls, R30 basement, triple pane windows way back then, and air-to-air heat exchanger. And it had, you'll notice there, the solar tubes. It had literally tens of thousands of dollars worth of solar tubes on the roof and on the wall, as you can see. And what they determined was, no matter how many solar panels they had, it's dark for so many hours in Saskatoon that all winter long, they couldn't get enough solar to heat the house. And so what they found, of course, is they would need some huge storage tank to put underneath and build, thank you, and to build, to have a reservoir of hot water. And it just wasn't practical. And that's kind of where the passive house idea comes from. Rather than trying to do active solar, could we find ways to do it more passively and not rely on the sunshine, if you will? So just a little thought there. And out of that, you do need to have an appreciation for that Canadian building science experience was indeed exported to Germany and United States. It's very clear the Germans came to Canada in the late 80s, found what we were doing, took it back to Germany, and admittedly made it more aggressive or let's call it more energy efficient. And they used that term of passive house rather than putting on tens of thousands of dollars worth of solar tubes. Could we try to avoid that? And the US took the R2000 information and turned it into Energy Star. And Energy Star is kind of the other way. Could we make it simpler? Not quite so far. Make it easier, more accessible. So as an example, since 1990 in Germany, there's been roughly, the numbers show, 25,000 passive houses built around the world. And maybe it's 30, 40,000. Energy Star houses, there's been over 2 million of those built in United States and Canada, over 100,000 in Canada alone. So the R2000 program, there was only 10 or 15,000 built. So you kind of have two approaches: make houses really, really energy efficient and only a few people can afford it, or make houses somewhat energy efficient, as you can see on the right-hand side, Energy Star, and more people will get access to it. So it kind of two different approaches, if you will, to energy efficiency. And just to continue that conversation, energy efficiency didn't make its way into the code until 2010. That is, the National Building Code finally said in 2010, we need to put energy efficiency specifically for energy efficiency. So we always had insulation in buildings, but now we have insulation or energy efficiency specifically as of 2010 in the National Building Code. And British Columbia has actually adopted now what's called a STEP code. So there's now this clear path forward of net zero ready houses by 2032. And in fact, the BC and the Vancouver Building Code has talked about all buildings being passive house by 2035, something like that. That is, they're enamored with this idea of passive house. And you'll see why in just a little bit, why passive house tends to make sense out in that Vancouver coastal climate zone. So just to give you a little sense, that's where we're headed. I've mentioned this to you before in other sessions for those who've been along, is this idea that there's this inevitable path forward to roughly 2030, 2035, where we would expect all buildings in Canada to be at a net zero ready or maybe even a passive house level. So that's where we're headed. But in the meantime, there are all these energy programs. So I've already mentioned R2000, kind of center left there. Some of you have heard of LEED buildings, and LEED is more than just energy. It has other elements to it. On the left-hand side, so this page is sort of going from left to right, low to high. The EnerGuide rating is what you've heard, the Greener Homes program that the federal government just announced. It's going to base this off an EnerGuide scale. So everybody who's going to have the million folks or so that they hope to have participate in the program are all going to have an EnerGuide rating done in their house. And there's no pass-fail to EnerGuide. It's just here, you have to have a rating done. Energy Star is always one step up from that. That is, it's typically 15 to 20% better than code. So when you build an Energy Star house, you're building a house that's 15 to 20% better than National Building Code. The R2000 program is 30 to 40% better than the National Building Code. And then you go to net zero and net zero ready houses. Those programs are targeting 50 to 60% better than code. And passive house is in the range of, well, about 80% better than the National Building Code. So various programs, various stages along the way. I would say to you, pick the one that best suits for your communities. Pick one, because frankly, you're all going to do this eventually somewhere along the path over the next 15 years. So if you want to start easy, start with Energy Star. If you wanted to say, I just want to be done with this and finish it right now, then you'd say, okay, let's go passive house. Let's just go all the way to the end and figure out how to do it. And then I thought I'd contrast for you or give you a sense of what passive house is about. And I thought I would show you just kind of difference between passive house and the common software that's used in Canada. So HOT 2000 is the software that was developed in the early 80s. It's now in version 15 or something, 11, I guess, version 11. Back, I started when it was at version 3, and now we're at version 11. It is held by the Natural Resources Canada. That is, it's a Canadian software program owned by the Canadian government. It's free. You can go download it free. Just Google HOT 2000. You'll be given a copy, what they call a general purpose copy. It won't necessarily help you with Energy Star or R2000 program, but you could at least start it and use it and so on. As I say, it's free. And in order to use the software on some of those programs, you have to become a licensed advisor. And that's about, well, I'm going to say it takes 6 to 8 months to become licensed by the time you write exams and so on. On the flip side, you have the Passive House planning package. They would say it's not a software per se, but it's an entire design tool from the Passivhaus program. It is available. There's a German version and a US version of it. In both cases, it's privately held. It's a nonprofit organization, the Passivhaus program, nonprofit. But in order to get the software, you have to purchase it, and then there's a licensing fee associated with it. And then in order to use it, to certify a Passivhaus, anybody can use it. But if you want to certify a house for Passivhaus, you have to be a licensed user. And that, again, is probably 6 to 8 months. It's a pretty intensive training program. But it's quite a nice tool, I will say that. It does a lot of interesting elements. But effectively, both of these are energy modeling software. Before you build a house, you design it on the screen. So you design it and say, I'm going to put R50 in the ceiling, and I'm going to put R20 in the walls, and it'll simulate the energy use. And the two programs give similar results, pretty similar results. Why? Because the physics doesn't change. The physics of heat loss across a wall in, Saskatoon, we talked to Saskatoon, is the same physics formula as the heat loss across the wall in Germany, for example. So it would be no surprise that you get similar results. How you interpret those results, of course, could be a little bit different. And again, I'm building up to Passivhaus, but hopefully you're okay with this. Canada has about 1 million houses have already been rated across Canada, and Canada hopes to do another 1 million. There's 13 million houses in Canada. We hope to have a couple million of them rated in the next 3 or 4 years. And it's simulation software that creates a rating for the house. And then the scale is gigajoules per square meter of house. So number of gigajoules. The label there on the left is showing a house that's 144 gigajoules of energy. That's the metric we use. And the goal, of course, would be to get to 0 gigajoules would be the idea. And the EnerGuide rating includes energy for heating, for cooling, for ventilation, for lights and appliances, for normal hot water, and energy produced on site for renewables. So that's the EnerGuide rating. And then I mentioned the R2000 program, developed in 1982. It based on $75 million worth of research at the time, and it was designed to demonstrate technologies. Lots of builders were trained, and it became the most researched, tested, and audited housing technology in the world. Nobody's done more testing than Canada on cold weather housing. And it was exported around the world as, say, Passivhaus. There's a program in Europe called the E3 program, and that's all based on R2000. And out of that, there was the software that you'll see here, or that we just talked about, the Hot 2000 software. And when you build an R2000 house, it's labeled and registered and put on file. And if you want an R2000 certified house, you have to work with an energy advisor, somebody like ourselves. We do a rating before the house is built. Then once the house is built, an inspection is done, testing is done, and then it's sent to NRCan for final approval, Natural Resources Canada, and the house is then labeled. So that's R2000. And then again, to contrast, the Energy Star program was actually started in the US. The housing program was developed in the year 2000, and it was brought back to Canada in 2005. It's based on the same building science as R2000, but it's simpler. It's only 20% better than code. It's not 50% better than code. It's 20% better than code. So it's simpler administratively. It's simpler technically. And we have lots of big production builders across the country doing Energy Star. Just, hey, I want to be better than code. That's where we head. It too is a labeling process. You certify the house at a very well-defined quality assurance process, permanent label kept on file, house is labeled on the electrical panel. A pretty simple, straightforward program to get to, although it still has quality assurance requirements. And now we get to what you guys came for. We talked about is the Passivhaus program. And let's be really clear. It was developed in Germany. Most of the Passivhaus work has been done in Germany. It is exported. There are people doing it in other places. And there is a Canadian offshoot of it and a specific US program. So I'm actually showing you on the left-hand side 3 different Passivhaus logos, because there are 3 different Passivhaus programs, which I'll come back to in a second. as I'll say again, it has very similar origins to the early R2000 program. It was very clear. Part of their research was to come to Canada, see what we were doing. Here's the big deal. It has a very, I'll say very rigorous energy budget that's applied to each house. And it's the same budget, whether you're building in Lower Mainland, in BC, whether you're dealing with the coastal regions, whether you're on the Saugeen Shores in Southampton, or whether you're down in New Brunswick, the same energy budget, and I'll show you what that is in just a second. And it has its own specific modeling software that has to be applied by specifically trained consultants. It has a very rigorous air tightness standard of 0.6 air change per hour at 50 pascals. I think most of you on this call probably have some understanding what a blower door test is, but we take the house up to 50 pascals negative pressure. And in this case, the house has to be lower than 0.6 or no higher than 0.6 air changes, which you'll see in a moment is a pretty significant number. And then it requires specific product certifications, or they are at least encouraged. So specifically, they would like you to use windows that were rated in Germany. That is, they use the rating, the European rating standards. So if you want to use a window, a Canadian built window, they're going to say, well, I need to know how it was rated. I need to know the European numbers, because that's what we put in our software. And if as a Canadian window manufacturer, you say, well, I don't have those numbers, then they give you a default number that probably doesn't give you full credit. I shouldn't say probably. It typically doesn't give you full credit for those windows. The same is true of HRVs. We have a nice, I would say, rigorous test standard for HRVs in Canada. It's a CSA standard called C439. The Passivhaus program goes, yeah, we have a different way of testing HRVs over in Germany. So ship your product over here. It'll be about $30,000 to $50,000 to test it, and we will give you our Passivhaus number. Okay, and because otherwise, they would say we don't know what to put in the software. And again, if you want to use a North American made HRV, you'd have to put in a default value, which maybe you don't get full credit for your what you're putting in. Now, there are a couple of Canadian manufacturers, one that I know for sure, that has an HRV that is small company out of Quebec that has a Passivhaus HRV tested to their standards. It's tested actually both to the Canadian standard and the Passivhaus standard, and the results aren't a lot different. It's a very efficient unit, but it at least was nice to see that it had similar results, if you will. So I just want to stick with Passivhaus for a moment and describe to you. I don't want to make it sound confusing. That's not the intent here. The intent is to understand the realities of, if you're saying Passivhaus, exactly what it is you're asking for or what it is you're building to. So the Passivhaus Institute is they would say the international body, and that's the original German program. And if you want the Passivhaus Institute to certify, if you want a truly certified Passivhaus Institute, you're sending your files off to Germany. Now, it may not be to Germany, but it's to somebody who's been qualified to review the file from the German program. And you have to use their software. Nothing wrong with that. As I say, it's a good software program. And it does encourage use of specific products. The last time I checked, which was for my own house 5 years ago, the fees were about $2,000 up front to get the software done. And then they said, and if you want to get it certified in Germany, it's probably going to be another $2,500, but we won't know until the house is done and when we send it off, and then they'll quote us and tell us how much it's going to cost. So that's the German program. There is a Passivhaus Canada group that adheres to the German program. So you're going to build to the exact same specifications as they are in Germany, except it's going to be validated by somebody here in Canada. So you're not going to get a Passivhaus label, you're going to get a Passivhaus Canada designation. You still got to use the same software, and yes, you have to use an accredited rater. It too encourages use of specific products. And again, the last I've heard, it's roughly the same dollars, maybe a little less than the German program. But I'll just stick with this just for a moment. In terms of the Passivhaus Canada, they're good folks. The software, when they do the software, it's not just giving you energy modeling. It's telling you some other things. It's talking to you about thermal bridging. It's telling you about performance characteristics of the house, or where there may be comfort issues. So it's quite a comprehensive software, which means it's a comprehensive training program. It's not just a piece of software that you can pick up and start using on your own. You'd want to take specific training. A typical Passivhaus training program is about 5 days, done online these days, good training. And then typically you mentor and work with somebody to become a rater over the next 6 to 8 months or so. So that's what you need to remind yourself if you're doing Passivhaus. Now, interestingly enough, unlike the Energy Star program and the R2000 program, both of those programs are trademarked. You're not allowed to say, I'm just like R2000 or I'm just like Energy Star. You're either an Energy Star builder or you're not. You've built an R2000 house or you didn't. And it's a permanent label on file at Natural Resources Canada. The Passivhaus program is not a trademark name, at least not at last I read. So you could say, I built just like Passivhaus, and nobody would know any different. So you sometimes hear this. I built the Passivhaus standards. What exactly did you do? Well, I put everything in they said I should put in, except I didn't do this and I didn't do that, perhaps. And there's really nobody to police that. But if you wanted an actual Passivhaus label, then you would work with either the Passivhaus Institute directly in Germany, or you'd work with the Canadian group. Now, a few years ago, the US folks set up their own program, and they call it the Passivhaus Institute of the United States, just to make things really confusing. So you will sometimes, in fact, I would say this label has more visibility in North America than even the Passivhaus Canada label. And they set up their own specific requirements. One of the things they didn't like about the German program is its inflexibility. It had the same energy target no matter where you built. And you can imagine the United States, you build a house at the tip of Florida, or you build a house at the tip of the Aleutian Peninsula, boy, those are two totally different climate zones, and yet the Passivhaus requirements were identical. You had to build to the same standard. So that was one of the key determining differences between Passivhaus US and Passivhaus Germany, or Passivhaus Institute. And the US program is more flexible in products. There's no real encouragement to use foreign built products. And because of that, and because it's a little simpler, my last time I chatted with somebody, the fees were about $2,000 or so to build. And I'll still say to you, there's, in the Energy Star world, you could measure those by hundreds of thousands of houses built. R2000, maybe 10, 15,000. Passivhaus, it's thousands of house builds, in the United States. There's maybe a few thousand a year built. So hundreds of thousands of Energy Star houses and a couple of thousand a year of Passivhaus buildings. And again, I'll describe a little more as to what the requirements are. I'm going to use the Passivhaus Canada requirements, Passivhaus Canada requirements. And here are the base requirements. One, you use, at the top there, you use Passivhaus energy modeling software. So before the house is built, before you start the house, you have somebody do this simulation, that $1,500 to $2,000 range. And it has a very specific requirement that no matter where you build, you cannot use over the course of the heating season, you cannot use more than 15 kilowatt hours of electricity per meter squared of usable floor area. Now, there's a lot to this phrase, so I'll go back to it. For the space heating component, so you take the simulation of the heat loss through the walls, through the windows, through the floors, through the system. We're not talking about the furnace. We're talking about the heat loss through the course of a winter in, as I say, somewhere in New Brunswick, somewhere in the on the west coast, the coastal region, you're going to simulate the energy use, and you're going to say 15 kilowatt hours per square meter of floor area. So let's start with floor area. If you built, I just did one 1,800 square foot house. It's a story and a half, 1,200 square feet on the first floor, 600 square feet on the second floor. That's 140 square meters, roughly 140 square meters of floor area. What did I say? 1,200 and 600, right? 1,200, 600, roughly 1,800 square feet. And so I would only be allowed to use, if you can do the math, 140 times 15, 140 times 15. So I'd only be allowed to use that small amount, 300, whatever that is, 380 or 400 kilowatt hours of electricity over the course of the year for space heating. Doesn't include lights, doesn't include appliances, just the space heating. The other phrase there, see there, is usable floor area. Passive house has an odd, I'm going to say a little odd idiosyncrasy to it. You're not allowed to count a stairway. So in my house, there's a stairway going upstairs. I have to take that out of the equation. So when I'm doing my takeoff, I'm measuring the house. I don't just measure the square footage. I have to take out the stairway. I have to take out, I think it's the mechanical room. It has these, and it's not, don't worry about it too much. It's just this odd little thing that you only get to take credit for what they would call usable or occupiable floor area. And then similarly, you simulate the energy use for space cooling. It too must be less than or equal to 15 kilowatts per square meter. And you're going to say, well, Northern Canada, we don't do any air conditioning, so you don't have to worry about that. But if you're building in Florida, for example, or Southern Ontario, you'd have to show that you weren't using more than 15 kilowatt hours. And then there's a second requirement, an alternate requirement, that the heat loss on the worst day, can't be more than 10 watts per meter squared. So let me use my house again, the 140 square meters. I'd only be allowed to have a baseboard heater of 1,400 watts. In other words, 1.4 kilowatt heater to heat the entire house. That's the base requirements. And you can say, well, that's probably pretty easy to do on the warm coast of out in BC, but I wonder if I could do that in Iqaluit or in New Brunswick or in Ottawa. And the answer would be, that's a really tough requirement. You will often hear the passive house folks say, yeah, you don't need a heating system in these houses. And that is true, except you can imagine the amount of insulation you're going to need in order to make sure you don't have that much, heat loss. And the fourth requirement, there are lots of others, by the way, requirements, you have to do thermal checks and so on. But in terms of numbers, the next one is the air tightness must be no more than that 0.6 air changes I mentioned before. And interesting little sidebar on the right-hand side, you have to do what's called a positive pressure test and a negative pressure test. That's an important piece. In our 2000 world, Energy Star world, Energuide world, we do a negative pressure test only. In Passive House, you do that test, and then you turn the fan around and actually pressurize the house. And this is important because backdraft dampers. So if you had a backdraft damper, say, on a bathroom fan, when you're doing the negative pressure test, that backdraft damper is being drawn back and it seals. But when you do a positive pressure test, that damper now opens and it leaks to the outside, which means if you're going to meet this very rigorous requirement, you're going to have to put a positive shutoff damper on your bathroom fan or not put in a bathroom fan at all, because you need a powered open, powered closed damper. Otherwise, it's going to just flap open. And then in addition to the simulation, you do this comprehensive design process review. You end up doing typically a design charrette. You send off your plans. Now it'd be done Zoom. Typically in the past, it was done in personal meetings. but the energy advisor, in this case, the passive house consultant, they call them, passive house consultant, would assess your plans for thermal bridges. You know, they would assess your plans for windows in the right orientation and so on. So it's a very comprehensive, and it's a good process. Architects actually like it. They would say it helps them build better houses. It also has a comprehensive quality control process during the build. You're checking in, you're sending off specifications of what you build. And then lastly, there's a comprehensive review of all the documentation before certification is issued. You have to send off a lot of pieces of information. Every piece of mechanical equipment has to be cataloged. The windows have to be cataloged. Send that off. Somebody reviews it and make sure you met requirements. So those are the base requirements of the Passivhaus program. There's a lot on that slide. The one I really want to key on though is that first one, space heating simulation, less than 15 kilowatt hours per meter squared of usable floor area, regardless of where you build. And you can imagine there are different styles and types of houses. When you think about the heat loss of a house, where it's going through the walls, this program is very subject to architecture. This program loves pretty much square boxes because you get good usable square footage for the amount of surface area of the house. If you built a long rectangular house, it wouldn't do so well in the Passivhaus software. So again, some architects like this because it helps them go back to basics and build simpler looking houses. Some architects go, no interest. It's really restrictive on my design. So you will sometimes hear people say they can spot a passive house from the street without having to look it up because the architecture is such that it really likes these well-defined cubes, tall, thin houses perhaps that are cubular and cubic in nature is what I would say. So those are the base passive house requirements. And I just wanted to highlight again this idea of the same passive house requirement, regardless of where you build. That is that 15 kilowatt hours is applied in the subarctic, the very cold, the mixed, the hot, humid, in all of those climate zones. And you might say, does that make any sense? And if you're talking passive house, if you're using that phrase passive, you would say, well, if I don't need a heating system in Windsor, Ontario, why would I have to have a heating system in Iqaluit? Why wouldn't I just build with more insulation? But fundamentally, here's a kind of an interesting map. Hopefully it's not too confusing. I found this on the internet. It's kind of interesting. It's kind of comparing Canada's weather to other places in the world. And you'll notice that most of Canada looks like most of Russia. Oh, okay. That, Canada's kind of falls into Russia. China is actually much warmer than Canada. China is kind of like southern United States. Over on the left-hand side, notice Germany is pretty much the southern part of, or middle part of British Columbia. United Kingdom, England, is pretty much the lower mainland. So when the program was designed in Germany, and they said it has to be the same energy use in all places within the country, they were thinking Germany. They weren't necessarily thinking Canada. And so I'm not saying it's a bad thing. I'm just saying that program was developed in 1988 in Germany, and they set the same target for every location. And now you get a sense of why the US said, we're creating our own program, and we're going to allow people to change the target. We'll change the target for various places. So hopefully that's of interest. I thought it was kind of a fun slide to look at as to where Canada compares. And you can see that we have a lot of the rest of the world is not nearly as cold as most of Canada is, most of where your communities are. So that's where it is. And again, I'm not saying it's a bad thing, but you'll see where we get to when in terms of amount of insulation and so on. So I'll just move along a little bit here. And I will say if we compared, say, Passivhaus to the CHBA, Canadian Home Builder Association, net zero program, I'm going to take a minute to do that. The difference with the CHBA program is it says, I don't care where you live, as long as your house, when it's designed, modeled, and constructed, only consumes as much energy as it produces on an annual basis. So in passive house, I can't add solar panels to make it work. In net zero, I can put on solar panels, say, hey, I'm in a northern climate. I guess I will put in more insulation, but I'll also put on more solar panels. The passive house program says, no, you're not relying on solar, or you get very small credit. You get some credit for solar, but not much. So that's the difference between the two programs. And I'll highlight that again in just a second. So in net zero, it has to be generated on site, if you will. And then there's this phrase called net zero ready. That's everything except the generation portion. So I wanted to give you a little difference there, just really quickly, and I'll finish up. The base requirements of the net zero home is you have to be 33% better than code. That is, you can't do it all with solar panels. You have to show that your envelope, your building, is 33% better than code. But after that, you just simulate and don't and make sure you can put enough solar on the roof or in the yard that makes up for it. And the air tightness is only 1.5 air changes. Now, you're welcome to go tighter, and you get credit for going tighter, but it's only a negative pressure test, and it's at 1.5. It has very similar quality assurance processes to Passivhaus. I mean, they're different, but similar in terms of their rigors. So it still has very rigorous Passivhaus. So I wanted to show you just a little example. This happens to be my net zero house. I'm showing you this as net zero ready. This is that 1,800 square foot house that I spoke of, 1,200 on the main floor, 600 in the loft up above. And here's what we built: an R60 ceiling, R30 walls, R30 under the slab. Sorry, R30, there is no basement. We actually put R30 under the basement slab. It's a slab on grade house, triple glazed windows, and it's under 1.5 air changes. And the incremental cost to do that was about $10,000 to $15,000. Now, of course, that's going to vary by your communities. I know many of you struggle in terms of product availability and can I get this stuff, but it's in that range for most builders. So that's what net zero ready looks like. Let me show you, sorry, I'll go to Passivhaus. Here's what when I was designing my house, they said, if you want to make it Passivhaus, here's what we're going to need. We're going to need not R60, but R100 in the ceilings. Not R30 in the walls, but somewhere between 45 and 75 in the walls. And so on. R35 on the slab. I did do R30, but they wanted R35 on the slab. And in fact, they wanted quad pane windows and that air tightness under 0.6. So frankly, the sum total of all this is, in order to meet that very rigorous, stringent 15 kilowatt hours per meter squared in Southampton, Ontario, near Saugeen Shores, this is what you'd have to get to. And you have to ask the question, is that worth it, right? Does that make sense? So I'll just go back and show you what that looks like in the difference between a passive house and a net zero house. So the passive house was only allowed to use 2,100 kilowatt hours. My house was using 3,500 kilowatt hours, or is using 3,500 kilowatt hours. And so it wants to be, in order to get there, I have to more insulation and ceilings, double the insulation and walls. And you worry about the practicality, right? That's a pretty thick wall. And the reason Passivhaus needs to be tighter is because there's more insulation in those walls. So there you have it. The Passivhaus would say, I only need a 1.4 kilowatt baseboard heater. My house needs 5.9 kilowatt heater, or in my case, I use a heat pump. And in the mechanical room, perhaps of interest, the mechanical rooms aren't a lot different between a passive house and a net zero house. It's a heat pump. It'll be a smaller heat pump in a passive house, so that helps. Typically a heat pump water heater, a high efficiency HRV with ECM motors, LED lights, Energy Star appliances. So not a lot of difference in the mechanical room of a passive versus a net zero house. And we normally say the incremental cost of the mechanicals is in that $5,000 to $10,000 range. So I just thought I'd show you that. And then just to, some are now moving towards energy storage. So some would say, especially in the far north, rather than running a generator, could I put in some energy storage? Just be clear, the biggest energy storage you can get in terms of electric solar is going to last you 4 or 5 days at most. So you can't make solar all summer long and say I'm going to save it for the winter. That doesn't happen. But it might help you over power outages and so on. So just keep that in mind as we go through it. And I'll just summarize and leave this slide up while we chat. Perhaps we have about 15 minutes left. I would say to you, all of the programs can work. Passivhaus is just I would say, our 2000 program or net zero on steroids, where it says, let's try not to rely on solar panels. Let's just make the house as efficient as we can. But you saw an example of just how extreme those insulation levels get to. Basically double the insulation in walls, and double the amount in ceilings, more than double the amount in basements or under slabs. And so, but the experience came from Canada, the science works. And of course, you're going to know each of your communities is going to have that different climate to think about. And obviously each community has different needs and different resource availability. So whether there's enough Passivhaus folks to be able to do your designs and your testing would be, I'm going to say, perhaps a challenge for you. So that was kind of the formal part of the program. John, are there any questions?
Hi, Gord. Claude here. Peter asks, is Energy Star primarily for RTMs?
Oh, I would say no. Ready to move. It can be done. RTMs. We know some of the RTM guys who say, "I'll build it for you in the factory." But frankly, the vast majority of Energy Star built are site-built houses. Site-built houses.
Thank you. A couple of posts regarding references to Passivhaus Canada. Certainly, to those sites are noted on the chat. Here's one from the real John.
Yeah, so Yale First Nations actually, I believe, is one of the first Nations to move to a passive house. They built a 4-story unit. I know that's my understanding, unless I noticed David Cooper, or Saskatchewan, or others, but that's the only one that I know of that actually used Passivhaus Canada specifications and built a place in Yale First Nations. And the cost savings, we interviewed her as part of our Home on the Res, our season 1, and she talked about the cost of passive housing before and after. And it was, if I recall, it was a substantial savings for them to move to passive housing. Like just electrical bills alone was well worth the additional cost for the passive housing construction.
There's no doubt there's a couple of things in favor, in terms of First Nations, a couple of things in favor of Passivhaus. One, in general, you guys do have pretty realistic architecture. You're not doing, really, I would say, outlandish architecture. And the quadplex, I think you said, or duplex, is a good example of that, right? Those are very efficient in terms of their wall structure versus the overall floor space. So because of, I'll call it realistic architecture in your communities, that helps. Second, you do have in many of the communities very high energy bills, and you don't have access to inexpensive fuels like natural gas. So by all means, you want to reduce. And again, in far north, you might go, well then, and because of the sunlight hours, we don't get a lot of solar contribution in the winter. So maybe we are better to spend our money on insulation rather than solar panels, because you're not going into the grid. So in my house, for example, on the left, I don't get a lot of solar contribution during the winter, but I get a lot of solar in the summer, and I sell it to the grid. So the local utility buys my solar power and then sells it back to me in the winter, gives it back to me in the winter. So I have what's called a net metering. So I can generate it in the summer and I can use it in the winter. Some of your communities would go, yeah, we can't do that. We're not connected to the grid per se. So the fact that we made it in the summer doesn't help us. We can't use it. So there are some reasons for you guys to go to Passivhaus. And I'll say again, to call it Passivhaus or to build Passivhaus doesn't necessarily mean you have to certify it to Passivhaus. You could simply use the principles, right? Of let's just put in more insulation. How much can you afford? How thick can you make those walls? That's totally fine.
Thanks,
Okay,
Corey.
go ahead.
John, did you want to bring up your other point here about windows and doors?
Yeah, so why wouldn't the industry then, if it's to their advantage, if I was a window producer or a door producer or an HVAC producer, and if the trends towards passive housing, you would think I would want to tailor my business to accommodate those requirements, wouldn't I? Like I find it a bit strange.
Well, I'll give you an example. The HRV manufacturers in Canada, there's 4 really good manufacturers, 3 at least, really good manufacturers. Each one of those have, I'm going to say half a dozen to a dozen models of HRVs or ERVs. Each one of those they had to have tested in Canada, and each one of those tests cost about 20 grand. It's a very well-defined set CSA standard. The Passivhaus, and I know a fair bit about this one because HRVs are near and dear to my heart. You want to get a unit tested in Germany, there's no specific standard. You send it to a lab, and there's 3 or 4, and the lab decides kind of what they're going to test to. And you pay $50,000 for each model. And then you'd say, how many passive houses there built in Canada? And the answer is about a couple of hundred. So why am I doing that? I already meet all Canadian codes. And here's what really kind of bugs me. Only one of the Passivhaus products actually meets Canadian standards. So for all their talk about they're more efficient, there's only really one German manufacturer that has gone about and gotten tested to be able to put a unit in a Canadian house, because Canada has very specific cold weather testing requirements for their HRVs. So I would say, I think there should be an international standard for HRVs. That would be my opinion. And anybody can test anywhere in the world to the same standard. Now, there are some conversations going on between the Home Ventilating Institute of North America and the Passivhaus Institute to see if they can harmonize standards so that you don't have to have the same unit tested to 2 different standards to get 2 different numbers that mean roughly the same thing. That's really the issue. And I would say things aren't going passive. Things are going to go net zero. I don't see us ever going to Passivhaus standards in Canada as a code. I see us going to net zero ready as code.
Gord, we have a question here from Albert. He's asking, are houses still being built to R2000 standards? Do you know that?
Yes, there are a few. He makes a good point. Thanks, Albert, for asking. The Maritime still builds some. But most now are just going to net zero ready. They might be using what's called the R2000 pathway to get there, but very few. My house we just built R2000. So there's maybe 100 or 200 in Canada. Well, I'll say it this way. There's about the same number of R2000 houses built as passive houses built, roughly the same. A couple hundred R2000, a couple hundred Passivhaus, and about 20,000 Energy Star houses a year. And about last year, I think it's close to 1,000 net zero houses built. So net zero ready has become the program of choice for most builders.
Okay, we have another one here from Peter. He indicates, although I understand the reason for this program, it appears to be overly complex, particularly for First Nations. Is there a simpler way to have some advantages of this program without the extensive complexity?
Yeah, I'm with you there, Peter. I like how you said you appreciated the need for it, right? Because it's in the early days still, and you want to make sure you have rigor and people don't make mistakes. There's that whole, we talked about in the last sessions about building science, making sure, you make the right decisions in the right order. If you're going to build lots of insulation, you got to make it airtight. So if somebody said on First Nations, I'm just going to put in R40 in the walls, but I'm not going to do that airtightness test, I'd say that's a bad idea. You'd want to verify your airtightness, but you might say, but there's nobody up here who can test for airtightness. Okay, then the community shouldn't build with R40 in the walls. Now, the cost of a blower door is not that expensive, and there's used ones around. So maybe the community buys a blower door, for $3,000-4,000, used one, and now you'd say, okay, we'll have a a blower door that's available to the community. So you're quite right, Peter. There's reasons for the complexity, but I will say to you, you could follow the principles of Passivhaus. That is, build it tight, more insulation, the right windows in the right location, proper ventilation, properly sized heating systems, without having to ship your files off to Germany or someplace like that. So you could follow the principles without actually certifying the house, and you do it quite comfortably, as long as you have some rigor to the process. Hopefully that answers.
Thank you, Gord. Peter indicates the map explains why the program appears to work best in BC. Certainly, I found that map very interesting, that overlay map of Canada versus a lot of those other countries.
Right. I did that too. I was doing a talk over in Italy on this same topic of, why doesn't Canada do Passivhaus? And I showed them that there's 27 cities listed in Germany on the ASHRAE weather data, 27 cities. Not one of them is as cold as Ottawa, Canada. So it's an entirely different climate. So you've got the idea right, that it really, if we were going to copy a program, we'd have to copy a Russian energy efficiency program, and there isn't one. So, in fact, we exported the R2000 program to Russia for that reason. So, we would say Canadian programs make more sense in Canada, for most of Canada. Not to say passive doesn't work. I sometimes people say, you're so negative about passive. No, I'm not. I think it's a great program. I just think it has complexity, and it's difficult for people in high prairie Alberta to do it. And difficulty doing it certainly in the territories, almost impossible. I'll stop sharing.
Okay, we have one about the impact of solar panel efficiency regarding snow cover.
Yes. So I get that a lot, and I'll go back to this idea. You don't have a lot of sunlight hours in the winter anyway, so the fact that it's covered with snow for a few days or a week or two doesn't hurt you that much. 2/3 of my solar in the Saugeen Shores, 2/3 of my solar is generated from end of April to end of October. So the little bit I lose because there's snow on the roof doesn't hurt you that much. Really doesn't hurt you that much. But you would say, depending on your communities, where's your power coming from? And if you're generating your own and you don't have a way of storing it, then yeah, you're right. Solar panels don't make a lot of sense because you need all the power in the winter and you don't get it until the summer. So that you're quite right. You'd have to look at individual communities. Where's my solar coming from? If I'm connected to the grid and they'll let me sell the power back or give me the power back, do a net metering, then it does make sense. But if you're not connected to a grid where they can use that power, then you're right.
I also see a question here about the Hot 2000. It's nice to see with reference to modeling diminishing returns on insulation that can be calculated.
Absolutely. That's the real power to me of Hot 2000. Literally we put a set of plans on the screen. We do it in Zoom calls all the time with our builders. And we simply say to them, what do you want to try? Let's put more insulation in the attic. We tried that. Oh, it didn't move the bar at all. Right. How about we put more insulation under the slab? Oh, let's try that. Oh, that moved the bar. So it's that way. Once you've got the model in, it takes about an hour to model a reasonably simple house. And then you can flip it around and try 6 or 7 things within a matter of minutes and make really good decisions as to where the bar, what moves the bar and what doesn't.
Yeah,
Who has access to the Hot 2000 modeling?
Who has access to it?
Yeah.
It's free software. You can download a copy of it for free. But if you want to use it for, say, code compliance or one of the programs, then you have to become a licensed energy advisor. And again, you'd work with a service organization, get training. First Nations folks have been trained across the country, but not that many because, are we going to use it? But the software is free.
Thanks, Gord. Just kind of a little side reference. Years ago, I taught the Hot 2000. It was part of our architecture program. We'd have the students design a house and make it as energy efficient as possible and use the Hot 2000 for modeling and basically indicate really how energy efficient that house design would be. or could be. So it was quite interesting as a learning experience for, we'll say, young architectural designers.
I totally agree. I think it's a great thing for them to see with the implications of what they're trying to do. And again, in First Nations, it's, relatively inexpensive to have. If you said, here's a typical house that we build in this area, wonder what it looks like on an energy model. Somebody like us could do that for, $500 or something like that. It'd be pretty simple to do.
Yeah, I was just going to say, we're again, we're working on this business plan where, FNBBOA creates this organization where, if, David or somebody's doing some building, we will have available people of your expertise and we will pay for that service to provide that to the communities directly, because it would take, for example, one call to us, and then we could say, okay, Gord, we need this done, or Bruno, we need that done. So we're looking at providing an organization where we're, providing guidance and assistance and helping to provide deeper capacity or background, because, most of everybody works in isolation.
Exactly.
And so we want to try to open those floodgates and be available.
And fellas, and ladies, my apologies. I have another call to attend to. Thank you for the opportunity. Again, you guys have been very kind to let me chat on these sessions, and hopefully that brought you some value. And if there are any questions, by all means, follow up with me or through John or Claude.
Yeah, appreciate that, Gord, and everybody. We have one more on Thursday, and then we're bringing our Junes to an end, and then summertime. So, but Gord is available for any follow-ups, and Gord, I will follow up with you, because this is a topic that Keith and I have been talking about, is bringing in that resource through this organization. So, because it's needed. So,
totally
all right,
agree.
everyone.
Thanks, guys.
Thank you, Gord.
Everyone.
Thanks, gang.
Thanks.